Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to complete this table for the radioactive isotope plutonium. So notice that we already have some information that's given, and then we have to fill up these gaps. Okay, so the half-life is given as 24,100 years, and then amount of the isotope after 1,000 years is 2.1 grams. So as you can see that from this table, what we are really trying to find is how fast the isotope is decaying. So this is the rate of decay. For the first part, see, the half-life is given, which means that after this many years, the amount of isotope has reduced in half from the initial amount. So we have to figure out what is that initial amount. And also is given that after 1,000 years, how much of the substance remain. And we have to figure out what happens after 10,000 years, how much of the substance is remaining. So since this is a rate of decay, we know that the rate of decay can be modeled by an exponential equation. So for a rate of decay, we can model it by the exponential equation, and it's of the form y equals c times e to the power kt, where t is in time, y represents the amount of substance remaining, c is the initial quantity, because notice that when you plug in t equals 0, so for time 0 at the very beginning, this exponential portion will go away and y is equal to c. So that's the initial amount. Now since we know that, go back here in the table and notice that this first gap that we have to fill is actually the value of c. That's what you have to figure out. Okay, and the k is the constant of proportionality. So let's try to figure out the c and the k for this equation. So we have a complete equation, and then we can try to fill the gaps. Okay. So let's see what we have. Let's take the very first information. Half-life is given. That means when t is 24,100, then y, the amount of isotope, is reduced in half, the initial amount. And initial amount is c, so y is c over 2. So we can plug these two values in the equation and then try to solve. All right, so let's do that. Y equals c over 2. The right hand side we have c, e to the power, k is unknown, and the time is 24,100. Okay. Let's multiply both sides by 2 so we don't have this fraction here. So we get c is equal to 2c e to the 24,100k. And notice right away, since both sides of the equation has c, we can cancel the c. So we have 1 is equal to 2 e to the power, whatever we have, and then divide by 2 both sides. And we have an exponential equation. We have to extract k from here. See, k is the only variable. And how can we do that? By taking natural log both sides. So let's apply natural log. Now recall that natural log and exponential functions, they are inverse to each other, and therefore they cancel each other. So the right hand side we can cancel out e and ln, and we will be left with whatever is in the exponent. So we have natural log of 1/2 is equal to 24,100k, and so you can figure out the value of k by dividing both sides by this number 24,100, and therefore k is ln of 1/2 over 24,100. And let's find out the approximate value using a calculator. So it will be easier for us to compute the rest of the values that we need to compute. So just pick any calculator that you have, and let's plug in natural log of 1/2 divided by 24100, and that's approximately equal to negative 0.40 and then 29. So that's the value of k. Okay. Let's move on and notice that now that we have k, we can plug in k in this original equation. Okay, what information do we have? We have another information from the table. So let's write down that as number 2. We know that after 1,000 years, so for t equals 1,000, we will have 2.1 grams of the substance, and therefore y is 2.1. Okay. Use these values, plug it in the original equation. So we have 2.1 is equal to, c is what we don't know, so we still have that constant unknown, and then e to the power k, now we know the value of k, so it will be negative 0.4029 times t, t is 1,000. And note right away that this is an equation with just one variable c, and we can solve for c. So let's simplify this a little bit. In the exponent, we have this entire thing multiplied by 1,000, and so we will get negative 0.029. And so how do we compute c? Just divide by this exponential expression both sides. So we have 2.1 divided by e to the negative 0.029. That is c. So let's write down the approximate value of c using a calculator again. So c is approximately equal to, let's see, 2.1 divided by e to the negative 0.029 is about 2.162. And so that we can write down here. So this is 2.162, and this is in grams. So that's the initial amount. Okay. To complete this table, we just have to figure out one more thing, and that is, what is the amount after 10,000 years? All right. So how do we figure out amount after 10,000 years? What does that mean? That means we have to figure out what is the value of y when the time is 10,000. That's what we have to figure out. And notice that in our original equation, we already have the two constants. We know c and k. So if we plug in the value of t, we can figure out the value for y. That's all we have to do. So take our equation and plug in. C is 2.162, and e to the power k is negative 0.00029 multiplied by 10,000. And then just plug that in your calculator and figure out the value for y. So if you want to simplify a little bit more, this is, see there, you're multiplying this entire thing by 10,000, so this is actually 0.29. And so plug it in, 2.162 times e to the power negative 0.29 is 1.618. And so come back here in your table and write down, after 10,000 years, the amount will be 1.618 grams. Notice that as time increases, the amount decreases. Makes sense because this is a radioactive isotope and is decaying. So this completes the table and completes the problem. Thank you.